Hello everyone. Today we have like a new video about a new software. Ensoft has like different software. We have discussed before Bile, which was used for the lateral loaded piles, and we have explored shafts, and this is used for calculating the axial pile capacity. And now we are going to discuss one of the other software. It's called Group. Group is a very good software, and it is used for analyzing the bile group. It's pretty simple. You can, but despite its simplicity, you can do lots of analysis inside, and you can come up with like lots of graphs that can be beneficial in the design. For me, I find it one of the most useful software when it comes to the fast, simple bile group analysis. And to learn it, it doesn't take that much time. You just need to have some knowledge about the topic in general. Like any other software, you will find in the top here, there are like file, data, option, view, computation, and graph, and window, and help. So if you want to data, you'll find you can create like new file, and data here, you can start to open title, you can add the title, and here you can start to build your bile group. Let's go for bile cross-section selection. So in this window, you can start to select the cross-section area of like the bile. So you can either has an elastic or non-linear. And if you clicked on edit, they start to give you the option to select the bile. So we have like a general bile here, which is a solid bile, and you can start to choose different section of the biles here. So we're gonna stick with general, and we're gonna like view the different other like section for the bile. So if you want here to section dimension, you can find the equivalent diameter. So let's say we have an equivalent diameter of 600, and once you do that, like here, you can start to add the section parameters here. And also, like if you want to the specification of the section, you can start to see equivalent the diameter. And back here to section draw, we can see like this is here the area, and here is the Young's modulus. So Young's modulus for the steel, it's like, let's assume it's 2.1 E8. Assuming it's a steel. If it's concrete, you can add E7 or any other like parameter, let's say 2.5. And the moment of inertia, if we assume this is millimeter, if you said it's 5, and here like you can start to select, like you can start to add like the bending moment and so on. So if you are choosing like general, you will have to add all these parameters by yourself. But let's say you picked one section here. So here start to tell you what is the diameter. So you tell the diameter, let's say 500 or 600, and you can say that the internal diameter here will be also 0. So it can be solid. If you want it like to be like a pipe, if you set the internal like will be 500, you can start to see the effect here. So we're gonna make it like only 0. So if you came here and you said calculate, they start to calculate the perimeter, the area, the inertia around ZZX and YY, and Young's modulus we already defined it to 0.5 E7, and shear modulus and torsion modulus and everything. So we already defined like a section here, and you can just say come here and look if you want to identify. This is just like, for example, one section, and we say close. So we're gonna call it section 1. We can add another section, and if we looked at it, like let's say we have like I-beam. So inside the I-beam here, you can start to select either to copy it from like the previous section, or you can just start to identify all the parameters: equivalent diameter, width, depth, flange thickness, web, and once you say calculate, they start to calculate everything, and you say okay. This is the way they calculate. This is the width, this is the depth, and all these parameter. I'm just gonna like define one section. I don't need like to define other section. I will say okay, and I will keep the response here elastic. So after that, you go to Bile Properties. In the Bile Properties, you can choose the bile, either like driven bile or drill bile. I will keep it like as driven bile. And here you can start to choose the top and the bottom. So I would say my bile length will be like 15 meter. And I will say okay here, and the whole length here is 15 meter, and I will say fine. Then you can go to bile group properties, and you can start to see the like the bile head. This is for bile number 1, bile number 2, but we have not choose the bile yet. You can go after that to bile head coordinates, loading, bile cap, soil. So let's look at soil. I will say that I will have soft clay, and the soft clay, it will be until depth of like 3 meter, or let's say 5 meter. And you can start to add the properties here. Let's say 15, 15, and undrained shear strength will be like another 15 kilonewton. 15 strain factor, I will add 0.002 or 0.02. Like you can find the recommendation, and you can add the ultimate skin friction. Here, ultimate skin side friction and ultimate tip friction. I would say here, this is, you can get like this according to the code that you are using. Each code has different constraints for these numbers. So this is something that you need to check it according to the code that you are using. So let's look here and say, what do they say? A linear interpolation with the depths, like if you haven't choose the bottom, he will say that he will like if you have different parameters at the bottom, it will interpolate according to the depth. Program will help you with estimating the strain factor if 0 is entered. So sometimes you don't have even to enter that, and the software will give you like a recommended value. So the program use the ultimate to generate the TZ and like the QW, and we can speak later in details about like the capacity of the ultimate skin friction. You can see that in different codes, like the Federal Highway Association. Inside this code, if you start to open it, you're gonna start to find that for the for the pile ultimate capacity, like you will find different values. In order like to download that, you can just go to here, and you say Federal Highway Association for example, driven bile. And if you want here, you will find like the book. You can just download it and start to look, and you will start to find the ultimate values for the end bearing and the side friction. This also can be calculated from the static equations. So if you want here like to chapter if you want here like to chapter, for example, um, axial resistance here, like you can start to see there are different ways for the calculation, as you can see here. And if you looked here, you can start to find, like I just want to show you that there are like tables for the axial capacity. yeah, such as here, for example, you can start the input factor. This is for like brown, this is for rock. Yeah, yeah, here, for example, like they have limiting for the unit 2 resistance. For example, like for the very loose medium sand, it's 40 and so on for each pile. And if you continue here, you can find also like there are other table that will give you some limitation. So you would like to check like this code, and they have like another code for the drill pile and other things. So this factors that you can like get it from like either the static equations or like from the restraints of like the code. So I will say okay, and I will add another row, and I will choose, for example, sand, and I will say the depth of the top layer, it will be like from 5, and the depth of the bottom layer, it will be until like 30 meters. If you went inside here, it's the same. It will ask you for the unit weight, so you can add the unit weight directly. He will ask for the angle of internal friction, so you can add for the internal friction. He will ask for the K and for the ultimate side friction and for the unit weight. So here for he's saying that a linear interpolation will happen between the first two rows. Always check the recommendation value for the geotechnical investigation to find the friction angle. Program will help you to identify K. K here like can be identified according to some codes, or you have like some test, and the ultimate unit skin friction tab, the program will use this value to identify. Always check the recommendation for the geotechnical report, and program will help you to identify these values if it was left zero. So it's either you add them or the program will help you, and this is the beauty of like this software. And we will just like add these values, and we will leave this value for the software to calculate them. So now I already showed like the soil bile cap option. So for the bile cap option, it will be rectangular, 0 and 0 and 0, and this is the thickness of the bile cap. It will be like half meter. Bile cap, sorry, dimension in y direction, it will be, let's say, 5 meter, and in z direction it will be like 5 meter, and the thickness is half meter. You can choose here that if the bile cap is embedded or not. And you can go through these details for more information about what's going on in this table. So now you can see here also like you can do everything from this tab, not from like data. So if you want here, this is the bile cross section, this is the bile properties, we already defined that, and this is for the bile group properties, and you can add like each bile and each pile. And here you can bile cap option, we just saw that. And if you went to here, like it can connect to L pile, and you can collect information from there and so on. If you looked at the 3D here, also, if you went to option here, you can find that you have like the unit. I'm using the SI unit. For the analysis mode, I'm using the 3D analysis mode. And also, you can see here that you can generate some options here, such as modify the bile group layout template. If I went here, this is like a fast template for like choosing the bile or creating the bile group. So if I select 3D here, I can say that the space increment in y direction, let's say it's 1.5 meter, and in z direction it will be like the same, and number in row the number in row, let's say I want it to be 5 and I want this to be 5. This is the center of the bile group. I want it to be like at 0, 0, and 0. And we have here this is also like for choosing the bile length. Select from existing. I have like existing one bile, so it's either you define a new one, bile, diameter, and modulus or so you can choose from the one that we just defined, which is 1, and I would say okay. So we'll start to tell you that will change, and I will tell them yes, fine. So as you can see here, since my bile cap was 5 meter by 5 meter and I added 5 bile with a spacing 1.5, it means that I need at least like 9 meters. So I will go to here and I will start, sorry, I will go to bile group properties. If you want to bile group properties, you see like there was only 2 biles. Now we have 14 bile, and each of them has its own properties now, and we'll come to this in a second. I just want to go to the bile group. This is also like the coordinates for each bile that I just defined. So you either had to go here or choose the other one. So I will go back to data and I will go to bile group properties. Sorry. Bile head coordinates, bile cap option, yeah. So I will say 9 meter by 9 meter and I say close. You see here now it increased. I can see that in the 3D or I have this now in the 3D. You can have like the 3D view or like XY here. It was a bit slow for me, and you can see the 3D view, and you can maximize. As you can see here, you can see X, Y, and so on all the direction. You can see that here. Um, yeah, it's here. So I just want the 3D view. Okay, so after you do that, like now we already defined the biles, we already defined everything. So now we are going to get to add the loads. To add the loads here, we already saw here that this is bile group properties. Inside the bile group properties, you can see you can choose either the bile is fixed or bend, or if you can add like spring modulus. For me, I will keep it as default as it is, or I can just like choose all of them to be fixed for all biles. So now I have everything is fixed. I have bile properties is 1. If you have multiple section of bile, you can change that. And I say okay. You go back here and you can start to look at each bile coordinates if you want to change it. So you have X and Y and Z and the angle and everything. So this is like for defining the bile coordinates. And you can see here that give you schematic here that give you every details. And after that, after you define your bile group, you can go to this is bile head coordinates. We already just saw that. You can go to loads. So you can either add load case. For example, here you can just add load case, and inside this load case you can add like dead load, life load, any kind of load, because you can make combination from them later. I will just assume the dead load here because I'm not focusing. You can like play with your problem as you want, as much as you want. This is just like a demonstration for this software. So also you can scale the load, which is very good feature here. You can see the effect of like the load. So I will go here and I will add just like one row, and I will add in x direction. In x direction, I will add like a load of I want to just like check one more thing. You see here that zx here is the vertical direction, and y and z here, they are the horizontal direction. So this is a very important thing, because when I add the load in x direction, it means that this is like the gravity load. And if I want to add like a lateral load, I will add it in like, for example, y or z direction. I will assume like y direction for now. I will go back again to loads here, and I will go inside here, and I will in x direction, I will just, for example, add 20,000 kilonewton. And for Fy, I will add like just 2000 kilonewton, and I will just keep it like that. Here you can start to specify many other options. For example, displacement load at the bile cap. You can specify a displacement. You can add like the type of load if you want to use a cyclic for By curve. You have like analysis option if you want to edit like the configuration, like the conversions and this and the bile segment and stuff. You can keep the default. Here, distribution of the lateral load. You can see, you can like create like a distribution for the lateral load, as you can see here. And this is just like fancy options. You can just look at them step by step. And here you have the foundation stiffness option. You can add like loading factor. Incremental pushover analysis. You can create the incremental pushover analysis and the displacement in either UX, UY, and rotation. Also, like it has like many interesting and good option for the use. I will just like keep the basic one for now. As I told you in a minute, that you can create load combination. If you have like multiple loads, you can come here and you can start to add like from dead load, and you can say the load factor, and you can add, but we only have like one, therefore we are only creating like one. I just gonna delete it, I don't want it, and I will say close, and I will say close. And here is bile cap option. We just like defined it. And yeah, like this is as simple as it is for this model. So now we start to run our software. So I will go to run. Now it already ran my model, and I start to look at the the computation. Then I can start to see the graph. You can generate many things here. So if I want to so this is the deflection in y direction. I see that my load, and this is for all biles, they are all the same. So because I didn't have any like group effect, and I can also like adjust the group effect in group to be automatic, or I can add it as to take into account as much as I want. So you can also show this is in z direction. You can see it's 0 because we didn't add any load in z direction. You can see the same for the shear, and same here, the shear in the other direction. And you can see here also this is shear in y direction. And sorry, that was like the bending moment. Then we are viewing the shear, scissor reaction, and so on. This is because there is no group effect. We don't see the group effect here. Also, you can do here in the graph, you can see you can generate axial force versus displacement. So we can see here that at loads of almost like 10,000 kilonewton, like we start to see the like the yielding and like the failure of the bile start to settle too much. And you can see here the bin graph with the generated torque and versus rotation. And you have here moment curvature, deflection in all direction. So you can see very good like very good like features here. And you can come here and say export this results to Excel. You can choose what result do you want to import to Excel, and you can create an Excel file. So let's see what is like how can we take into account the group effect, because now we are not sure if the program is taking a group effect or not. So we're just gonna close this, and if we went to option, this tab we said like it has many different options, and you would like to go through them in details. So if we looked in the option here, there is like a reduction factor for the lateral load. So if you want in the reduction factor, you can say either ignore the effect or specify you must enter like reduction factor, or you can just like let the software automatically generate that. And the way that the software generate that, the software start to look at the load, start to create like a set or a matrix of like factor, it dependent on what? Depending on the location of each pile to the pile surrounding it. So the leading pile, the trailing pile. For example, if we look here at this view, it's a bit slow. Yeah, here. Assuming that I already added loads in y direction. So it means that this set of piles are the leading pile, and the pile at the back here, there are the trailing pile. It means that the pile at the front will exhibit like higher lateral load compared to the back piles, because there will be like a gap between the pile and the soil. Therefore, the maximum soil resistance will be somewhere here. So each pile, for example, this pile in this software, when we do like an automatic account for the lateral group effect, that this pile will start to have a factor from the leading pile and have a factor from the trailing pile, and the same from the side piles, and also will have an effect from the skew piles here. So there will be like a factor. If you went to the manual of the software, you can start to find like how do they calculate that. Like we can try to show you here. The software will give you like an example of how do they calculate the group factor effect. Group effect. So that would be like in the technical manual. Anyway, as I said, it is calculated through some equations, and depending on the piles around it, they come up with like a factor. So let's go back to option and we activate that. We already made it automatic. And analysis, define reference pile cap movement estimated based on the following cap. I will keep everything as default, and I will just run the analysis one more time, and I will go here to see the deflection. You can start to see here the effect. Let's increase the load a bit. Like before, it was all the piles were like on top of each other. So I will see here, go back here, and I will make this also like increase it 10 times, and I run, and let's go to see the deflection. you can start to see the group effect here. Like there are like difference either also in the bending moment. You can see the difference in the bending moment between the piles before taking into account this effect. So this is like just a demonstration for the L pile. There is lots to say about this pile. I encourage you to review if you are like a user for the Ensoft groups. It's a very good software for designing and analyzing the pile group. It has lots of feature and you can go to the technical manual and the user manual to learn more about it. And I'm happy to answer any of your question. Thank you. I will end this demonstration at this point and see you in the next videos.